Physics 2122 Lab 1, Charge Tapes by Sarah Dea. So for the introduction, the purpose of this lab is to use two identical strips of charged clear tapes, U-tapes, find the charge of the tapes, and witness the transfer of electrons within the system as the tapes interact with different objects of varying charge. We also need to simulate the interaction between the two U-tapes in GlowScript/VPython. The results of the lab are that the strips of tape have equal charge, therefore repelling each other. The tapes are positively charged. The charge of the tape is 3.9 times 10 to the negative 9 coulombs, and the tapes are deficient of 2.45 times 10 to the 10th electrons. We made the assumptions to ignore air resistance on a moving object, treat a long tape as though it were a point charge with all the charge concentrated at the center of the long tape, and assume that each U-tape you made had around the same amount of charge evenly distributed along the length of the tape. We are making these assumptions so our calculations will be easier to do. We can pretend that our system is a closed system so that there are only two forces at play, when in actuality they aren't. Our expectations were that the two U-tapes will repel each other because they are the same charge. If the U-tape is positively charged, the pen and the tape will be attracted to each other. If the U-tape is negatively charged, the pen and the tape will repel each other. If the tape is neutral, the pen and the tape will attract. We use three main principles of physics. Coulomb's law, which showed that the electric force from a charged object is equal to the constant k times the charge of the two objects divided by the distance squared. Newton's second law that showed that the force is equal to the mass times acceleration, which is then shown in the force of gravity, F equals mg. We're using these principles because they are the two forces that are acting on the tape B, and we will use them to find the exact charge of the tape. Our experimental model is this. The system consisted of tape B and tape A. The surroundings are everything besides the tape, and the initial conditions are the two pieces of equal length tape and one piece of base tape. Our procedure was to create the charged U-tapes by ripping the strips of tape off the base tape, place tape B on a raised platform sticky side up, raise tape A until tape B begins to float. The reason we did this was so that the electric force of tape A upon tape B would be equal to the gravitational force of Earth upon tape B. When tape B begins to float, the net force is equal to 0, meaning that the force of gravity is equal to the electric force. So this is our procedure of the lab. These are the raised platforms. This is tape B, and this is tape A. And we can see this is when the tape B begins to float. And this is the interaction between the tapes. So this point is tape B when the net force is equal to 0 when it begins to float. And that's because the force of tape A, the electric force of tape A, is equal to the force of gravity on tape B. Pretend these some observations that we made were that the U-tapes repel each other, the U-tape and the human figure attract, the U-tape and the pencil case attract, the U-tape and the charged plastic pen attract. Thus, the tape has a positive charge. And these observations are the same as the expectations we made in the previous slide. So our data and calculations. So these are our constants. 1 meter of tape is equal to 0.001 kilograms. The length of the tape is 0.22 meters. The mass of the tape is thus 0.0022 kilograms. The width of the tape is 0.02 meters. And gravity is 9.8 meters per second squared. The distance between the tapes as tape B begins to float is 0.008 meters. And the length of an atom is 1 times 10 to the negative 10 meters. And these are our calculations. You see we set the gravitational force of tape B equal to the negative electric force of tape A upon tape B. We got the charge using that calculation. The final results are the tape is positively charged. The charge of the tape is 3.916 times e to the negative 9 coulombs. The tape is 2.45 times 10 to the 10th electrons deficient, and the ratio of deficient electrons to atoms is 5.56 times 10 to the negative 8. This is my code. As you can see, the forces upon tape B and tape A are shown. This is tape B and this is tape A. The force of gravity and tape A's electric charge upon tape B. I also encoded the calculations from the previous page so the program would calculate the output of the charged tape, which is exactly what we got in our calculations as well. So what if the electrons had positive charge and the protons had negative charge? It wouldn't change the observations we made because whether or not the charge is negative or positive, like charges repel and opposite charges attract. The tape would instead be negatively charged. Why is it important to handle the tapes as little as possible? Because neutral objects and charged objects attract, and due to the tape's electron deficiency, it attracts to ourselves to borrow our electrons. So if it is in too much contact with other objects, its positive charge will wear off and the experiment won't work. Some possible sources of error or actual problems were contact with the tape and the surroundings, external forces caused by air conditioning, and the tape charges may not have been as equal as we assumed. In conclusion, through observing interactions between the two U-tapes, we proved that we are able to find the charge of an object through the use of Coulomb's law and Newton's second law.